and this is 9E. And today what we want to be able to do is find the side lengths of right triangles in 3D shapes. So last time we learned Pythagorean theorem. And Pythagorean theorem, remember, was a squared plus b squared equals c squared. And this was for a 2D shape. This was for a right triangle, right? Where I had two sides that I was worried about, A and B, right? And we could use A and B to help us find our hypotenuse, or the diagonal part of our 2D shape. And so if I'm thinking about this, right, it's kind of like the areas of 2D shape. And same thing, we're finding the diagonal of a 2D shape here when we figure out what's happening here. So that being said, I want to be able to find the side lengths of right triangles in a 3D shape. Well, what was the difference between a 2D shape and a 3D shape? Well, in a 2D shape, right, I'm going to draw me some. In a 2D shape, remember, I have two sides that I'm concerned about. But in a 3D shape, I don't just have length and width, I also have, or length and width, I also have height. Length, width, and height, instead of just length and width. So the difference between a 2D shape and a 3D shape is two sides versus three sides. Well, same idea is going to apply. I want to find the diagonal in a 3D shape. Here's my diagonal in my 3D shape, and it goes from, like, let's say this top front corner all the way to the back opposite corner, and it kind of goes through the middle of a box. If you're thinking in your mind about a cardboard box, this would go kind of down through the center of my box from the top corner all the way down through to the bottom corner on the other side. So think about that. Well, if I'm there's a couple of different ways that I can do this, but I'm going to teach you the quickest way to do this. Remember, when I had a 2D shape, this makes a right triangle in here, right? And I have a couple of different right triangles that are in here. I can use this idea of three side lengths. We're going to kind of use the quick method here in order to be able to find the diagonal, but I have three sides instead of two sides. And so when I had two sides, remember, a squared plus b squared equals c squared. Well, the same thing is true for a 3D shape. It's just that now I have three sides. A squared plus b squared plus c squared is equal to my diagonal squared. So three sides instead of just two sides. And what is happening here is I have A, B, and C, right? And so a squared plus b squared plus c squared equals that diagonal squared. I'm using the side lengths there, a squared plus b squared plus c squared. I'm using all three of my sides here in order to be able to find the diagonal. So three different side lengths, and I do the same thing. Same thing as I did before with Pythagorean theorem. I'm going to take my side lengths. In this case, it's 2, 6, and 10. And I'm just going to put them in there. 2 squared plus 6 squared plus 10 squared is going to be my diagonal squared. 2 squared is 4, 6 squared is 36, 10 squared is 100. That equals diagonal squared. 4 plus 36 is 40 plus 100. 140 is my diagonal squared. But I don't want diagonal squared. I just want to know what that diagonal is. What is the length of plane D? So I can take the square root of this side. I can take the square root of that side. These will cancel out and leave me with D equals the square root of 140. And 140 is equal to 2 times 2 times 5 times 7. My 2 is going to come out, and my 5 and my 7 are going to be my remainder. So 2 square root of 35 is equal to D. And I can do that for any 3 side lengths. I can kind of use the same idea of Pythagorean theorem, only this time I have 3 sides instead of just 2 sides that I have to worry about. But the Pythagorean theorem works with 2D shapes, with 3D shapes. I just have to remember that I have an extra side with my 3D shape. Okay, so what I'd like you to do is pause the video. Try this on your own. You've had a lot of practice with the Pythagorean theorem now. Try this diagonal theory for 3D shapes and see if you can make it work. Okay, I hope you paused the video and tried this on your own. With my diagonal, a squared plus b squared plus c squared equals the diagonal squared, d squared, right? So here's my 3 sides, 3, 5, and 7. I'm going to substitute those in to my equation here. So I'm just going to label these A, B, and C. And so 3 squared plus 5 squared plus 7 squared is equal to D squared. 9 plus 25 plus 49 is equal to D squared. 9 plus 25 plus 49 is 83 is equal to D squared. But remember, I don't want D squared. I want to cancel out that squared. So I've got to take the square root of both sides. That's going to cancel out and leave me just D. And the square root of 83 is prime. 83 is prime, so I cannot factor it. So I'm just going to leave it as the square root of 83. And there's my side length. Okay. All right, the last thing that we have to do is we have to be able to find the distance. So now we're looking for the length of sides on a graph. So kind of bringing back into play some of our graphing skills. We're going to find the distance between 2 points on a graph. And here's lots of different kinds of graphs are happening here. But we're going to use our Pythagorean theorem to help us. A squared plus b squared equals c squared. And I can actually use the Pythagorean theorem to help me find the length of a line. So we're not finding the slope. The last time we had 2 points on a graph, we were looking for slope, right? How steep the line was. And this time we're not looking for steepness. We're looking for length. How long is that line? And we can actually use the Pythagorean theorem to help us because any line, diagonal line on the graph can be made into a right triangle. And we can use that right triangle to be able to figure out the length of the line, or let's say the area of a square. So let's take a look at these first couple of graphs. They kind of look a little bit different, but let's take a look at these graphs that have squares on them. I'm looking for the area of the square. And I also want to know what is the side length? So what is the length of that line? How long is it? How many centimeters or how many inches, right? And so the way that we do that is we actually draw in a right triangle. And we say, okay, well, the side of a square can be turned into a right triangle. And I can actually count how many boxes long each side is, right? Now, before when we did this, we were looking for slope. How steep is it, right? What is its rise over its run? But now I'm looking for length. How long is it? And what is the area of the square attached to that side? Well, I can use Pythagorean theorem to do it because the length of that line is 2. The length of this line is 2. And so the diagonal line would be my C. And I can use those lengths in order to be able to figure out what is the area of that square. So I'm going to take my Pythagorean theorem and I'm going to substitute in, I'm going to call this one A and this one B. I'm going to substitute in the side lengths of the right triangle that I drew. So 2 squared plus 1 squared equals c squared. 2 squared is 4, 1 squared is 1, equals c squared. C squared is 5. So now I know the area of that square is 5. I can also figure out the side length by taking the square root. This is going to cancel, and c is equal to the square root of 5. 5 is a prime number, so we can't simplify it or reduce it, so we just leave it as a square root. So now I know the length of this line from there to there is equal to the square root of 5. Okay, what I'd like you to do is pause the video, try these other 2 little squares here, draw in a right triangle, and then count up how long is this line. Let's say each one of these represents 1 centimeter or 1 inch. It just depends on what size of graph that we have, right? But if each one of these things represents an amount of length, right, then we can use this idea of the Pythagorean theorem to find out how long a side would be. So pause the video, try it on your own, come back and check your work. Okay, hopefully you paused the video. I'm just gonna slide that over, I guess. I need to lock that into place so that it doesn't keep sliding. I'm gonna kind of erase some of my markings here so that it's more obvious what I'm trying to do. I'm gonna lock this in place so that it doesn't keep sliding around on me. Okay, so I'm gonna start with this big one on the bottom. I'm gonna draw in a right triangle on the side, and it doesn't matter where I draw it. I could draw it over here. I could draw it up here. I'm going to pick a side. This is a square, and so each side is the same length. It doesn't matter where I draw my triangle. So if you draw your triangle on a different side than mine, it's fine. It should still work out. We should get the same length of the line. So this one is 2 boxes long. This one is 1, 2, 3 boxes long. And so my side lengths are 2 and 3. And remember, my diagonal side is always C. So one of these is A and one of these is B. And I'm just going to substitute it into my Pythagorean theorem. A squared plus B squared equals C squared. So A is 2 squared plus 3 squared equals C squared. This will be 4 plus 9 is equal to C squared. So 13 equals C squared. I know that 13 is the area. So based on, do I want the area of the square or do I want the length of the line, right? Whatever my question is asking me on my homework, I could find both. Here's the area, 13. The length of the side would be take the square root, and C is equal to the square root of 13. 13 cannot be factored. It's a prime number. And so the length of the line is square root of 13. How did you do? Okay, let's do this last one. It is 1 by 1. And so I can use my Pythagorean theorem, A squared plus B squared equals C squared. And I can substitute in my side lengths. And so 2 is equal to C squared. The area of this box is 2. And the side length then would be the square root of both of those. Those would cancel. And C is equal to the square root of 2. The side length would be the square root of 2. And 2 is another prime number, so we can't simplify that square root. And so we just leave it. It is equal to the square root of 2. Okay, how'd you do? Hopefully you checked your work on those and you're feeling okay about it. All right. Okay, so what about if I have a graph? So let me